So remember, it's practice is important now. Got to practice so we could grow in the subject. All right. So don't let it pile up. You got to stay on top of it. So let's put this down. Let's talk about this, and then we will go to probabilities. So you could take this down. So what I'll do is give y'all some stuff to practice on what we did earlier, and then that stuff you'll send to me. And remember our deal. Y'all gotta make sure you work on it, send it to me, and practice. Remember, we practicing the first few times we were practicing good. Don't let that fall off. We continue to practice straight through exams. Okay? Alright, so let's talk about a sample space. So a sample space refers to all the possible outcomes or events in a random experiment. So let's use an example, right? You guys know what a die is, right? So basically, like when you're playing snakes and ladders and them kind of stuff, y'all know about dice, right? So those numbers would be 1, 2, 3, 4, 5, 6. That's your possible sample space because those are all your possible outcomes. Does that make sense? So if you have a die and you want to roll it, okay? You want to roll that die. Yeah? Okay. Y'all know as a die? A dice. Yeah, like dice is a plural. Die is a single. Yeah? So you got dice. If you roll a dice, if you roll a die, right? You have 6 options. So those would represent the possible outcomes or the events. Okay? So that's what we would refer to as the sample space. Okay? Now, if I had a coin, what would the coin sample space be? What would the coin sample space be? Heads or tails, right? So if we had it for a coin, it would be heads or tails. So if you look at this, this is the die. The die would have 1, 2, 3, 4, 5, 6 as an option, and the coins would be just heads or tails. Does that make sense? Lovely. Good. Everybody understand? All right, so you could take this done quick, and then after we go through some stuff. All right, so sample space for playing cards. Y'all know about cards? Okay, ace cards. Oh, all right. So y'all know playing cards, ace cards, right? What is a sample space for that? What are the options? How many options do we have? Possible outcomes. Anybody know? How much we have all together? Yeah. Close. 52. 52. Remember, right? So we got an ace, which is like 1, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And after those 10, we got jack, queen, king. So that 10 plus those jack, queen, and king would give us 13 for the clovers. Then we got 13 hearts, 13 spades, and 13 diamonds. When we add all of them together, we get 52. So this here is a sample space for playing cards, right? Make sense? All right, good. Now, what is probability? So probability refers to the chances of an event happening or not happening. So we're talking about what is the chances of a particular event happening when we have all these possible events. Okay? So the probability of a certainty or something happening for sure is 100%. That means like, yep, that's definitely going to happen. The possibility of it not happen at all, like it's no way it could happen, we say that is 0%. So basically we can reference it like this. So certainty is like, yes, it's going to happen. Impossible, there's like zero chances. And an even chance would be if we got a unbiased heads and tails. So when I say unbiased heads and tails, all I'm trying to say is we don't have a coin that is heavy on one side and light on the next side. It has an equal chance of being on any side. All right, so take this down. So y'all got it? All right, good. All right, doing good. We pushing good work, man. We pushing good work. So this is basically like the last big part of statistics. Outside of this would be like stuff like bar graphs. You know how to do bar graphs. Y'all been doing bar graphs since y'all born, right? Then pie charts. Y'all know how to do pie charts as well too, right? In terms of like it's a full circle, 360 degrees. Um, each the proportions, how to work it out in that kind of way. Hmm. Yeah. In terms of what, like which part, like yeah, like say for instance, if it got like you want to find out what angle each of them would represent, all you got to do is put a fraction times it by 360, that kind of thing. We could probably send you out some stuff to try just to see how y'all handle it. And then if anything, we just go through it. All right, let's go now. So this here, the probability that an event A will happen is written as this, like this here. So this means the probability of event A happening. So then the probability for that would be the number of favorable events. So that's basically what you want to happen over the number of total events or the total possible events. All right. So that's how we basically calculate it. So in a bit, we're going to go through some examples of how we would work out probability. So we could get a rough idea of how probability works and how we go through it. So the probability that an event A will not happen is written as that. So this one is just for extra knowledge. All right. So example. What is the probability of flipping a coin and obtaining a head? What is the probability of flipping a coin and obtaining a head? We'll do these orally. What is the probability of flipping a coin and obtaining a head? So, one out, one out of two. Lord, you make that sound so easy. So, number of favorable events, number of total events. So, we know that the number of favorable events in this case would be one. And then the number of total possible events, two. So, one out of two. That's correct. Yeah, I'll make that one look easy. Let me try do it for this one now. So flipping a coin to obtain a tail would be what then? One out of two, right? Okay, so one out of two, which is like a half. We could also put it as a percentage. So we basically convert half to percentage, right? All right, so example three. What is the probability of pulling a queen in a deck of cards? You sure? 4 to 52. Everybody agree or disagree? Agree. Teja, so cards, right? From the picture we had showed before, it's 52 cards. Okay? And each of them got a queen. So I'll show you the picture here now, right? So let me see if you understand now how we could get a probability. So the favorable events in this case would be 4, right? Because how much queens we got? So the queen is the ones with a Q. You see? Uh-huh. So we have 4 queens, and the total number of cards we have is how much? 52. So that's how we get 4 out of 52. Does that make sense? Yeah, yeah. I follow. I follow that. Usually cards like something that kind of common, but you have one or two people who still not sure about cards. Okay, so what is the probability of pulling a black card in a deck of cards? A black card.
50%?
You sure?
Yeah, 50%.
50%. So we have 26 possible blacks because we got 13 here and 13 here. And the total possible events would be 52.
52 I have.
Exactly. So 26 out of 52, which is basically the same as a half, which is also the same as 50%. Okay, does that make sense?
Yeah.
Lovely. All right. So, what is the probability of rolling a die and obtaining a 5?
1/6?
1 out of 6. Nice, because we have.
One six, 1 5 7.
All right. Lovely. Y'all in it, man. I got it. Okay, so next one. What is the probability, check this one out, of rolling a die and obtaining a multiple of 3?
3/6.
3 out of 6, you sure?
Wait. 1/6. No. 2/6, I think.
1 out of 6, 2 out of 6, which one? So, before we do that, let's ask ourselves, what is a multiple of 3? So, multiples of 3 would be like what? What's the multiples of 3?
369.
369. Good. So we have 2 out of 6. Lovely. Because we have two possible outcomes, and then it's out of 6, right? Two favorable outcomes out of 6 possibilities. So 2 out of 6 are 1/3. Make sense?
Yeah.
All right, so let's check this one now. What are factors? Before we answer that, what are factors? The factor of a number would be what?
Numbers you can multiply to obtain a number.
Numbers that could go into a number equally without a remainder.
Remainder.
Okay, good. So it says here, what is the probability of rolling a die and obtaining a factor of 12? So, before you answer this, see if you could find the factors of 12.
5/6. 5/6. Yeah. 5/6.
You sure?
Yeah.
Good. Excellent. So there are 5 numbers that could go into 12 equally. So we have 1, we have 2, 3, 4, and 6. All these numbers could go into 12 equally without a remainder. Okay? So, therefore, the answer would be 5 out of 6. Excellent. Make sense?
Yeah.
Yeah? All right, good. So, let's talk about something called contingency tables. So, this is another form of how we could use data, put it in a chart, and represent this information, and also calculate probabilities from it as well too. So this table basically like shows like a combination of categories and the frequency for each of those combinations. Okay, so below we have a table, and we're gonna say these are students that like and do not like homework. So this here is a perfect example of a contingency table. So we have boy, girl, that's one part. And the next category is like homework, does not like homework.
Okay, that table they look wrong.
It look wrong?
Yeah.
Love it, love it, love it. Alright, so what I want y'all to do is take down this information, right? So I want to ask some questions to make sure that you understand how this is read. Okay, so all together, how many students do we have?
100.
100 students. How many girls do we have?
49.
49. How many boys like homework?
43.
43. Good. How many girls do not like homework?
19. 19.
All right. How many students love homework or like homework?
73. That wrong though.
73. All right. So I want y'all to take this down, and then we're going to be using information from this table as well too. Is this something you guys saw before? Y'all ever saw this before?
Like third grade.
All right, got it now, right? Everybody got it now? Make sure you got this done.
Yeah.
All right, so notice what this question is asking for, okay? It's asking for the probability as student. So they're talking specifically about a student. So when they're talking about a student, it means in general. So we refer specifically to a student. All right. If I wanted to refer only to the girls, it would say a probability of a girl being selected that does XYZ. You see what I'm saying? Or probability of a boy being selected and does XYZ. Now, in this case, it's asking to select as student. So when we are focusing on the selecting as student, we are looking at the overall score as the total possibilities. Now, it says, what is the probability of selecting a student that is a girl?
49 to 100.
49 out of 100. Anyone does not understand that? Make sense?
Yeah.
Yeah. Keelan, you understand?
Yeah.
Nice. Good. So 49 out of 100. So, Josiah, it says here, what is the probability of selecting a student that likes homework?
73%.
73 out of 100. Right? Or 73%. So 73 out of 100. Okay? Now, it says, what is the probability of selecting a student? Again, now we're still selecting from the pool of student that is a boy and likes homework. 43 out of 100. Excellent. Good. So, what is the probability of selecting a student that is a girl and does not like homework?
19 out of 100. 19.
Nice. 19 out of 100. Okay. And remember, once we're doing probability, we want to see something in this form, like 19 out of something, or we see it as a percentage. Okay. So sometimes, people would make the mistake and just drop 19 and forget probability, and I remember sometimes, like as a student, I used to forget sometimes to put that part because you kind of bypass the part that says probability and you just go, oh, selecting a girl that does not like homework. So you just say, oh, no, that is at 19. Clean forget that it's a probability. So you have to be careful with that. All right. So notice what we are selecting from this time. Okay. Notice what we are selecting from this time. So, what is the probability of selecting a boy who likes homework? So, remember last time we were selecting a student. So, selecting a boy now. So, a boy, how many possible boys do we have?
51.
51. Now, the question is asking if we were to select a boy, not a student, we're selecting a boy. So we're looking in that particular area here now. All right. We have to select a boy. What is the probability that that boy likes homework? What do you think is going to be?
8 out of 51.
8 out of 51. Why did you choose 8?
Because it's talking about the boys and not the like students.
But remember what it says, selecting a boy who likes homework.
Oh yeah, who likes homework.
So it should be what?
Selecting a boy who likes homework. Yeah.
How many boys like homework?
8 out of 51.
You sure? Read that again. How many boys?
Oh, shoot. 43 out of 51.
43 boys like homework out of 51. Good. You got it now. So we are looking at 51 this time because it says selecting a boy. Okay. Previously it said what? Selecting a student. So we were looking at the total students. This time it says selecting a boy. Okay. Let's look at the next one. It says, what is the probability of selecting a girl who does not like homework? So take note of what our focus is now. Selecting a girl. Before we were selecting a student, then we selected a boy. Now we're selecting a girl. 19 out of 49 because we're selecting a girl out of the girls, those who do not like homework. So out of the girls, because we're selecting a girl, we're not gonna select any boys. We're selecting a girl. We have 19 who do not like homework out of 49. All right, make sense?
Yeah.
All right, so let's talk about mutually exclusive events. Okay, so basically, mutually exclusive events would be a situation where they cannot happen at the same time. So, for instance, in a deck of cards, if one card is selected, it would either be black or red. It could not be black and red. You understand? You can't have a card that's red and black. Obviously, it could have mixtures in the sense of like it got a little thing of red here, a little black of here, but you know what I mean in terms of the typical deck of cards. It's usually red cards, which would be like hearts or diamonds, or black cards, which would be like clovers and spades. So that's what we mean by mutually exclusive. It cannot happen at the same time. You're either up or you're asleep. You're either writing or you're not. You're either, So that's why it says mutually exclusive. All right, so we got it now, right? Everybody got it now?
Yeah.
All right, good. Okay, so let's look at this example now. So it says, what is the probability of rolling a die and obtaining a 1 or a 2? So we're rolling a die and we are trying to see if we are going to obtain a 1 or a 2. Man, I make that look so easy. 2 out of 6, right? Because the first option is obtaining a 1, which is 1 out of 6. The second option is obtaining a 2, which is also 1 out of 6. So when we add them together, we're going to get 2 out of 6. That makes sense, right?
Yeah.
Okay, good. So, what is the probability of rolling a die and obtaining a 5 or a multiple of 2? So, a 5 or a multiple of 2. 4 to 6. Yeah, I'll say that so quick. Got me here thinking. Yeah? Good. So probability of obtaining a 5 is 1 out of 6. And the probability of obtaining a multiple of 2 is 3 out of 6. So when we put that together, that is 4 to 6. Y'all got it, man? Y'all getting it? Okay, so what is the probability of selecting a student? Notice what it says. Selecting a student that is a girl that likes homework or a boy that does not like homework. So we see the group that we're selecting from as student. We're selecting as student.
48 out of 100.
38 out of 100. How did you get that?
Cause like I read a question and I say selecting student that is a girl that likes homework or a boy that does not like homework. So I had add 40 and from the girls who like homework and 8 from the boys that don't like homework.
Correct.
Out of
So the student that is a girl that likes homework is basically 30 out of 100. A student that is a boy that does not like homework is 8 out of 100. So when we add those together, we get 38 out of 100. Does that make sense? Yeah? Good. All right. Everybody got that. So, Clayton, you had to understand that one?
Yes, teach.
Yeah, you got that one? All right, good. So, let's look at this one now. What is the probability of selecting a student that is a boy that likes homework or a girl that does not like homework?
62 out of 100.
So, how you get that now?
Cross adding.
Oh gosh, just cross.
Alright, that what I do.
Break it down for me. Break it down for me.
So I went for a bar that likes homework, which is 43 of them. Then I add the 19, and it gave me 62.
All right. So when we have the first option, boy that likes homework, as you said, 43 out of 100. Then a girl that does not like homework, 19 out of 100. So we add those two together, which gives us 62 over 100. Everybody get that one?
Yeah.
Yeah, Teja, you get it? Teja?
Teach, my thing just shut off. So you can repeat, please?
Asking if you had to understand how we get this 62 out of 100 for this one.
Yes.
Okay, good. All right, so the other type of probability that we have is independent events. Okay, so that's when the outcome of one event does not affect the other, right? So we usually use this for when we are able to replace stuff. Okay, so say for instance, just imagine you had like a fridge, and in that fridge you just had like unlimited yogurts and biscuits, right? So you have yogurt, you select a yogurt. Every time you take out a yogurt, one just pop back automatically. Or you take a biscuit, a next one pop back automatically. So that's what we refer to as like your replacement. So it has a replacement. So once it has a replacement, when you select one now and you select one later, they don't affect each other because whether you take one or two, the next time around you still could take one or two if you wanted to. Okay? So this is something that isn't so popular in CSEC so far, but sometimes they just pop it in here or there, right? But so we roughly go through it just to get a rough idea of what it is. So I'll let you guys write this down, and then after we'll check out some other stuff and then continue on the probability. Because then now we got to look at it from the cumulative frequency point of view. Once we could do that from the cumulative frequency point of view, we'd have that part covered. So next class, God's Fair Life, I want us to work on some past paper style questions for this topic as well as review certain things. So make sure y'all do all the homework assignments that I send y'all and get that completed, get that done packed. So when you're doing that, you can actually like flow through it and do it like really good. Alright, y'all got it down? Yeah. Alright, nice. So check this out now. So we got this word here, greatness. So what is the probability of selecting an N and then an S with replacement? So we basically saying let's take the letter N. We're selecting the letter N and then it can go back. Then we could select the letter S. Alright? That's what we mean by replacement. So what's the probability of selecting an N? What's the probability of selecting an N? 1 out of 9. Good. What's the probability of selecting an S? 2 out of 9. No. The fact that this question said with replacement, I know that my first selection of the N would not affect my second selection of the S. So therefore, I know, okay, in this case, this particular instance here, this would be independent, right? So then now, since it's independent, it's basically telling me it's independent, I would multiply both of them together. So you see when we was doing mutually exclusive, the keyword was R. So you could either select this or that. In this case, it's saying we're selecting this and then this with replacement. Okay, so then when I multiply those together, I get 2 out of 81. So y'all follow that example what we did in this case here? Yeah. Yeah? Okay, good. All right, so next one again. What is the probability of selecting a vowel? You guys know what a vowels are? Yeah. Good. So what is the probability of selecting a vowel and then a G with replacement? I'll let y'all work this one out. Yeah. 49. 4 out of 9. 4 out of 9, you sure? That would be, what you saying would be selecting a vowel or a G. Oh. We saying a vowel and then a G with replacement. Be 3 out of 9 and then the second would be 1 out of 9. And then what do we do with that? Add it. Multiply them. Multiply them. Why are we multiplying them? I can't remember. Just see the last thing you do that and then multiply them again. Because they're independent. All right. Okay, so the probability of obtaining a vowel is 3 out of 9. Then the probability of obtaining a G is 1 out of 9. So we multiply that and we get 3 out of 81. Okay, that's it. So, y'all saw it, right? Yeah. All right. So this one here now. What is the probability of rolling a die and obtaining a 1? Then rolling a die and obtaining a 3. 1 out of 6 and 3 out of 6. We got three trees in a die. Oh no, 1 and 1. 1 out of 6 and 1 out of 6. Yes, good. And what do we do with those? Multiply them since they're independent. Nice. And you get 1 out of 36. 1 out of 36. Excellent. Good. So that was just a little example on that, right? So the last part that we have to do now is when it's above or below a given value on a cumulative frequency curve. So just write on this part and then we're gonna go through it. We just got 4 examples of these, and then basically I'll finish probability. I'll do a big push today, and then next class we're gonna just do some other stuff and then practice papers, go through them. So y'all soon done your first topic in the CSEC exam. Write this down and we're gonna go through the chart. So the same charts that we were using earlier to do the upper quartile, lower quartile. So remember guys, I gave y'all a homework assignment last time to go through that, right? Now we're gonna see why it's important. We need to know how to do that. So y'all have to make sure go through all those and then practice them so that you could implement this stuff that we're doing. This stuff is very easy, but you need to practice it. You got to practice it. All right, y'all got it down? Yeah. Y'all been understanding what we're doing so far, right? Yes. Good, but we gotta remember, we gotta practice. So let's say we had this here. So this was the one that we did long time, the first one we did. So 9.5 was the boundary for 0, so forth. Who remembers how high this one went to? 18. Excellent. Now, this question says, what is the probability of a student spending less than 20 minutes commuting? So first things first, all together, how many possible students do we have? 18. 18. Lovely. 18. Good. Now we need to figure out about a spending less than 20 minutes. So what axis do you see minutes? What axis is minutes? X-axis. So I need to look for 20. So what we are doing here, okay, follow me here. What we are doing here is the opposite of what we do when we're trying to find the median, the upper quartile, and lower quartile. So this time we coming from the other way. So this is 19.5. 20 is about here. So if you had a guess based on what I just told you, right? What you think I would do with that line? What do you think I would do with this 20 here? You draw a line up. Nice. So this here represents 20. So we got 19.5, 20.5. So that means 20 is in the middle here. What do you think we're going to do next with that line that we just hit? Go across to the y-axis. So we just went across, and this value here is 8. Okay? So it says less than 20 minutes. So everything that is less than 20 minutes would go this way. That means the first 8 students did 20 minutes or less. Y'all following me? So because we're going less here, we also go less down here too. So we're going down. All right. So basically from here is 8 students. Okay. 8 students right here. So 8 students took less than 20 minutes. So what is the probability of students taking less than 20 minutes?
8 to 18.
8 over 18. Does that make sense?
Yeah.
Everybody follow that one?
So you can explain that one more time.
Okay, so we start from the beginning. So we said, what is the probability of a student spending less than 20 minutes commuting? All right, so first of all, I need to figure out where the 20 minutes is. Okay, so here is 19.5, here is 20.5, and we keep going. 21.5, 22.5, 23.5, 24.5. You follow me?
Yeah.
So where's the 20?
Below the 20.5.
Good. So if you check that out, right? If here is 20, I'm looking for the part that says 20 minutes. And I found it on this axis, 20 minutes. So now to approximate that, I need to draw the line up. Okay? And then once I hit this curve, I go across. Good. So then here now represents 5, 6, 7, 8. So I'm saying that 8 students, because remember, if we're going in the order of lowest to highest. So that means if I'm saying 8 students, that means the first 8 students took up to 20 minutes. Okay? The other students above 8 took more than 20 minutes. But we want the people who took less than 20 minutes. So those who took less than 20 minutes would be those same 8 students. Okay? Does that make sense?
Yeah.
So then now, that would be the probability. The total number of students is 18. Thus the probability is 8 out of 18. Alright?
Yeah.
Kaylana, make sense?
Yeah.
Yeah? Josiah, make sense? Alright, so this time we're saying more than 20 minutes. Okay? More than 20 minutes. What do you think is the first thing I'm gonna look for? Alright, so we got 20. Nice. So 20 now, we do the same mark again. We hit that line, come across, and this is 8. But the thing is now, it didn't say less than. This time it says what? More than. So if it's more than here, we're going up here, which is more than. So 10 students, okay, did more than 20.5, 20 minutes, sorry. Okay, so 18 students is together, but only 10 did more than 20 minutes. Does that make sense?
Yeah.
So therefore, the total number of students is 18. So the probability would be 20 out of 18. Y'all follow that?
Yeah.
Good. All right. So let's try it for a last one now. We do the back and forth with that same one too. So say with this one here now, we're going to do no more than 15 minutes. So what does no more than 15 minutes mean?
15 minutes and back.
15 minutes or less, right? So what do we do here? What do we do with this 15?
Find 15 minutes on the chart.
Find it on the chart on the x-axis. So we know here is 15.5. So here got to be 15. Okay. So we find that 15 here. What do we do next? Draw the line up. Good. Then the next thing we do is across. Good. So this number here is roughly 1 to 2.5. So I would say 2.5. Now, we said no more than 15, which is the same as saying less than 15. Okay? So we're looking at everything that's less than. So therefore, the probability of somebody spending no more than 15 minutes would be what?
2.5
Out of
out of 18. Sorry.
18. Good. Don't forget that part. Remember we talked about that. Don't forget that. Good job. So 25 students. Say again?
So that can have 0.5 of a student.
Yeah, you can't have a point five. That's a good point. You can't have a point five of a student, but just in terms of probability, it allows us to look at it as a proportion. You know what I mean? So yes, we can have like 2.5 of a student, but in this case, what we would say is like that just represents the proportion or the probability of that happening. You know what I mean? Which is a fair point. Okay, good spot. All right, so 2.5 out of 18 would be the probability in this case. Okay, making sense? Y'all following? It's the same concept like what we did just now earlier, right? And the only time we do this if we're doing probability, sometimes they could ask you, the number of students who did 15 minutes or less. We're using the same chart, you just need to know where to use it from. Some cases you have to go from X to go to the Y. And when we're doing the upper, lower, median, we go from Y, hit the line, then come down to the X. All right? So, last one. It says no less than 15 minutes. What does no less mean? No less than mean?
15 minutes and go onward.
All right, good. So, what do we do in this case? Same thing we look for where the 15 would be. So, if this is 15.5, 15 would be here. All right. So, what do we do next? Line up. Then we go across and we say 2.5. So if it says no less than 15 minutes, what do you think the probability would be?
15.5 out of 18.
All right. So 15.5 out of 18. Okay. 15.5 out of 18. Lovely. So this is our answer right here. Okay. No, this here trying to get like a wrong, but this is what we focusing on right here. All right. Good. So that's a rough idea of how this is. This is for you guys to try now with some questions and so forth. And guys, please make sure you practice. Don't sleep on it. Don't say, "Oh yeah, that was easy. I understand that." You gotta practice it. You got to practice it to reinforce the concepts. All right. So that was probability, and we also did the measures of dispersion. Y'all did a lot today, which is really good. Proud of how y'all were able to cover all this stuff. So all we got to do now, guys, is practice. All right. So make sure you go through all the stuff that we did. I'll send you all some stuff to try as well for homework. So continue to work hard on this. All right. All right. All right. You guys have a good night. Okay.
Alright, good night.
All right. Good night.